Venus has a surprising secret. It is a planet shrouded in thick, swirling clouds. This world is often called Earth's twin because it is similar in size, but Venus is very different from our home. It holds a mystery about the way it moves. This secret makes it unique in our solar system. We are going to explore this strange feature. It challenges what we think we know about planets. Understanding Venus helps us understand everything. Our solar system is a busy place, full of wonders. Planets orbit the sun, each with its own characteristics. Mars is the red planet, known for its rusty dust. Jupiter is a gas giant, a colossal world with many moons. Saturn has its magnificent rings, a truly breathtaking sight. Earth, our home, teems with life and vast blue oceans. Then there is Venus, a planet of extreme heat and crushing pressure. It appears as a bright jewel in our sky, but its surface is hellish. Many planets spin in the same general direction. This common direction is called prograde rotation. It is as if they all agreed to dance the same way. This spin is usually counterclockwise when viewed from their north pole. This is the way Earth spins, giving us our familiar day and night. This consistent pattern is a clue to how our solar system formed. It suggests a shared origin from a spinning disk of gas and dust. But Venus, our celestial neighbor, breaks this rule. Venus does not follow the crowd, it spins its own way. This is not just a minor quirk or a small difference, it is a fundamental aspect of its planetary nature. Imagine all the dancers in a grand cosmic ballet. Most twirl in one direction, a graceful, coordinated movement across the stage. Then, there is Venus, spinning deliberately in the opposite direction. This backward spin is one of its most fascinating secrets. It makes scientists ask many questions. Why is Venus so different from the others? Most planets in our solar system rotate prograde. This means they spin in the same direction as their orbit around the sun. Think of a spinning top moving in a circle. The top spins, and it also travels around a central point. For most planets, these two motions are in harmony. Earth spins this way, Mars spins this way. Jupiter and Saturn also follow this pattern. This common direction is counterclockwise, looking down from the sun's north pole. It is the standard cosmic dance. Now let's talk about Venus. Venus is a rebel in this cosmic dance. It exhibits what scientists call retrograde rotation. This means it spins in the opposite direction to most other planets. It also spins opposite to its own orbital direction around the sun. So while it travels counterclockwise around the sun, like Earth, its axial spin, its day, is clockwise. This is truly unusual in our solar system's family of planets. Only one other major planet, Uranus, has a highly unusual tilt that is almost on its side. Imagine looking down upon the solar system from high above the sun's north pole. You would see almost all the planets spinning counterclockwise. Earth would be turning, revealing its continents and oceans. Mars would be spinning, showing its reddish deserts. But then your gaze would fall upon Venus. It would be slowly, very slowly, turning clockwise. This backward spin is a profound difference. It sets Venus apart in a very dramatic fashion. It is a mystery that has puzzled astronomers for decades. This retrograde rotation is not just a small detail, it has significant consequences for the planet itself. The speed of this backward spin is also remarkable. Venus rotates incredibly slowly. A day on Venus is longer than its year. We will explore this more later. For now, understand that this backward spin is key. It is a fundamental characteristic that defines Venus. It makes it one of the most intriguing objects in our celestial neighborhood for planetary scientists to study. It challenges our models of planetary formation. Because Venus spins backward, something very strange happens there. On Earth, we are used to the sun rising in the east. It climbs across the sky and then sets in the west. This daily journey of the sun is a basic rhythm of life. It dictates our days and our nights. We watch beautiful sunrises paint the eastern sky with color. We see fiery sunsets in the western horizon. This is all due to Earth's prograde, or counterclockwise rotation. Our planet spins towards the east. Now imagine you were standing on the surface of Venus. If you could survive the extreme heat and pressure, of course. And if you could see through the thick, perpetual clouds, you would witness a sunrise quite unlike anything on Earth. On Venus, the sun would appear to rise in the west. It would then slowly, ever so slowly, traverse the sky. And finally, it would set in the east. This is the complete opposite of what we experience. It is a direct result of Venus's retrograde rotation. This backward journey of the sun across the Venusian sky is mind-boggling. Think about it for a moment. Every morning, the source of light and energy would appear from the west. This simple fact would change your entire perception of the day. If there were any life forms, their rhythms would be different. Their understanding of direction would be oriented differently. Our terms east and west are tied to the sun's apparent motion. On Venus, these familiar concepts would be reversed in a fundamental way. Adding to this strangeness is the length of a Venusian day. Venus rotates incredibly slowly on its axis. One day on Venus, meaning one full rotation, takes about 243 Earth days. But its year, the time it takes to orbit the Sun, is only about 225 Earth days. This means a day on Venus is longer than its year. This combination of slow, backward rotation is unique. It makes the concept of a day on Venus very different from ours. The Sun would move across the sky at a snail's pace. This backward spin of Venus is a major puzzle for planetary scientists. Why does Venus rotate differently from most other planets? Our solar system formed from a giant spinning cloud of gas and dust. This cloud, called the solar nebula, collapsed under its own gravity. As it collapsed, it spun faster, like an ice skater pulling in their arms. This initial spin should have given all planets a similar prograde rotation. So, Venus's retrograde motion needs a special explanation. It is an anomaly we must investigate. Scientists have proposed several theories to explain Venus's peculiar spin. One leading idea involves a colossal impact in its distant past. Perhaps a massive, planet-sized object collided with a young Venus. This impact could have been so powerful, it might have reversed its original spin direction, or it could have knocked it so hard that it slowed down and eventually started spinning the other way. Such giant impacts were common in the early solar system. They shaped many of the worlds we see today. Another theory suggests that the dense Venusian atmosphere played a role. Over billions of years, strong atmospheric tides created by the sun's gravity could have acted like a brake. These tides, combined with friction between the planet's core and mantle, might have gradually slowed Venus's rotation. Eventually, they could have even caused it to flip its spin direction. This is a more gradual process than a giant impact, but it could also explain the slow, backward rotation we observe. It's a complex interaction. Understanding why Venus spins backward is more than just solving a cosmic riddle. It helps us understand how planets form and evolve. It tells us about the chaotic and violent history of the early solar system. Studying planetary rotations, including unusual ones like Venus's, provides crucial data. This data helps us refine our models of solar system formation. It shows the incredible diversity of worlds out there. Each planet has its own story, its own journey. Venus's story is written in its backward spin, a testament to cosmic forces at play.